Hi everyone, so we're going to get started. Thank you for coming, and we have a huge turnout on the Eventbrite, so there are a lot of people who wanted to come and a huge wait list. And just a couple of things to go over before we get started. There's food in the back, there are drinks, so get up anytime that you want. The bathrooms are actually out by the elevators, and the hashtag for the event is DC-VA TUG if you tweet. And just some other announcements that I need to make. So in order for these user group meetings to happen, we need people to present and we need people to host the event. So if you are interested in either of those, please come see me at the end. We can talk through logistics. And then lastly, does anyone else have announcements? I actually have one. So after this event in the evening, starting at 6 o'clock, there's going to be a Data Plus Women event, which is also going to be here. And it is women that are in the data field and coming together. And it's not just limited to women, so guys can come too. We're just going to be talking about women in the data field, though, and how men can be advocates and what women can do to help themselves in the data field. So does anyone else have announcements? I know some people might have job announcements.
Thank you. I just wanted to make a quick announcement about a job opening with our company that I work for. We're Base2 Technologies, a small government contractor. And right now we have an opening for an analyst with 3 to 5+ years experience, preferably somebody with 2+ years experience using Tableau to create dashboards and reports. It's long-term. Right downtown near the New York Avenue Metro Station. And right now they're offering 4 weeks paid time off to start, competitive salary, 100% paid for health and dental, paid parking in Metro, and so on and so on. So if anybody's interested in getting the job description, I have a few printouts. You can also see it on dice.com if you search for our company, Base2 Technologies, and that's BASE, number 2 Technologies. And like I said, I'll be around, so if anybody wants a copy, I can give you one, or trade a business cards and send it to you via email. Thanks.
Hi, I'll be shorter. I'm Alex Blakemore. We're also looking for good Tableau, data visualization, data science people. We're mostly in Virginia. A lot of our work is to government agencies, so really looking for U.S. citizens. But if you love data viz and data science, we have great benefits. Send you to the Tableau conference, anybody who wants to join up. So come see me afterwards. The company's name is Apogee Integration, and I'd like to take you to Austin with me. Bye.
I'm going to make a quick announcement. I'm Caesar. I put together, I'm one of the co-hosts of the Government TUG, the Government Tableau User Group. We're virtual, we're pretty much a virtual user group. But we are looking for speakers or anyone, specifically anybody, if you work in 508 compliance or any compliance things for our next event, actually our July event. Our next event is coming up soon in May. We've got Andy Kriebel, who some of you guys may or may not know. Excellent presenter, and also Jeff Mills from Tableau talking about how to source and find Tableau rock stars. So if you're looking to hire Tableau rock stars, maybe you guys want to watch. So please come by and talk to me later on.
Anyone else? Okay. Anyone that's in the back, we still have seats up here in the front if you want a seat. And with that, I'm going to introduce our first speaker. So John Schwabish is an economist, writer, teacher, and creator of policy-relevant data visualizations. He is a leading voice in the researching. He is a leading voice for clarity and accessibility and how researchers communicate their findings, and he is currently writing a book. And he's going to do some
swag.
Yeah, some Tableau swag.
Some Tableau swag. So it doesn't eat into my time, just to be clear. So Brittany has lots of contacts at Tableau, so we have a box of Tableau swag. So we have, what do we have here? We have, not really maybe, Tableau user group t-shirts. They're very soft.
And we have some glasses that say party with your data.
Why not? So we'll give 5 of these away now, right?
Yes.
And we'll give a few more away later.
Yeah.
Okay. So what are we doing first? T-shirt? Okay.
Yeah, sure.
Okay, ready? So for the T-shirt, and you can come get it later. For the T-shirt, first person to name the creator of the following visualization. Ready? You don't count. Speakers are ineligible. Gentleman in the back. Okay, one right there. All right, ready? T-shirt number 2. And once you win, you're ineligible for more prizes. Okay, ready? No, but not close. Nope. Okay. No, no one gets that T-shirt. Like that on my taste. Okay, that's Joseph Priestley from 1769, History of the World. All right, ready? Number 3. Later, right there. This T-shirt right there. Okay, number 4. We're going to move into the modern times. Ready? Come on now. You got to know the wind map. Really? All right, everybody has homework tonight. You have to go to see the wind map by Martin Wattenberg and Fernando Villegas from Google. You have to go. This is homework. You have this as an assignment now. Okay. You've all earned a homework assignment. Okay. Last one, and then we'll give more away later.
Yep.
Okay. This will be a mug.
Sure.
This is a mug. All right. Ready? You don't have to do the name. This is the design firm.
I'm surprised.
Really? No one knows who did this. I'm shocked and appalled.
I'm surprised.
There's
Yeah.
a lot of education. This is from Periscopic in Portland. This is on gun deaths in the United States. Also,
It's actually animated.
It's actually animated. I just grabbed the still. So you have more homework tonight. So the next TUG will have a test. All right. So we'll figure out how to do more.
Yes.
Later. All right. So we get 2 teachers. Okay. Anything else?
No, that's it.
All right, so I'm going to talk about how to do a better job communicating data. We're all here because we are interested in data, and that means we need to be interested in communicating data. If you are an analyst, or a researcher, or a scholar, and an academic, the work doesn't just end when you've made the graph, or you've written the report, or you've written the journal article, and it just goes off into ether. Especially now, we need to be more and more concerned about how we are communicating our work, communicating our visualizations to our audience. And this idea that data needs to be communicated better is, of course, not a new idea. In the early part of the 20th century, Charles Schwab, the steel magnate, owned a number of steel mills around the country. In a story he tells in a couple of his books, he visits a steel mill in Ohio, one of the most underperforming mills in his empire, as it were. And he asks the manager, why are you underperforming? And the mill manager says, I have no idea. I have tried everything. I have tried carrots. I have tried sticks. I have tried incentives. I have tried everything I can do. We can't seem to improve our production. So Schwab grabs a piece of chalk, and he walks over, and he says to the mill manager, how many units of steel did you produce today? And the mill manager says, we produced 6. And so Schwab takes that piece of chalk, and he writes a big number 6 on the floor. And he walks away to do what big bosses do. And later on, the night manager comes on, and he says to the day manager, what's the deal with the big 6 on the floor? And the day manager says, well, Schwab was here earlier, and he asked how many heats we produced, and we produced 6. And so he goes off home, and lo and behold, he comes back the next morning, and the number 6 has been erased and replaced with the number 7. And shortly thereafter, that's replaced and replaced with the number 8, 9, 10, 12. Because numbers provided the incentive for people to do better. And numbers were communicating that information. Now, when it comes to modern sort of data visualization, I have a view that people need 3 core primary skill sets to create effective visualizations. The first is some understanding of statistics, how to work with data. We're talking about data visualization, so everything sits on a bedrock of being able to work with data, be able to analyze data. So some understanding of statistics. The second skill set is some understanding of design, how aesthetics matter, how color, font, layout, user experience all matter to bring readers and bring users into the visualization and then to keep them there for as long as we want them to be there. And then finally, if you're interested in creating interactive visualizations, perhaps outside of Tableau, some understanding of programming languages. Typically, this means JavaScript and D3, some Node, some Python. Now, when I teach data visualization, I get people all the time who want to become experts in all three of these within the course of 3 hours. And I say, that's not going to happen. Those people, I call those people unicorns. Those people don't really exist, right? And the goal is you're working with your data and thinking about visualizing your data in better ways is to not try, I don't think, to try to become a unicorn. It's to try to build teams in which together you are unicorns, where you have people who understand data and understand how to work with data, download it, extract it, analyze it. People who understand design and what that means. It's not just about color and font, how layout matters, how design can move the communication forward. And then programmers who can take that information, put it into an interactive visualization so people know how to use it, interact with it. Okay, because visualizations are so important, from John Medina's great book on brain rules, the more visual input becomes, the more likely it is to be recognized and recalled. This is why we want to visualize our data, because people are more likely to remember that information if you present it to them visually than if you present it to them as a table, or as a series of numbers, or as a bunch of text. So what I'm going to do today is I'm going to walk through is kind of a negative talk, I won't lie, I'm going to try to tell you some things to stop doing in your everyday visualizations, okay? So, and I'm going to branch out a little bit, I'm going to do some data, I'm going to do some data visualizations. I'm also going to talk about presentation design, presentation skills. As Brittany mentioned, that's the book I'm writing right now. So I'm going to talk a little bit about slide design. So, first off, check out this Venn diagram. If you are going to create cards that you're not particularly familiar with, you need to be very careful. Look at this Venn diagram, take a look. Okay? This is not a firm you want to work for. Okay, right? You want to work for a firm where trust, partnership, innovation, performance are part of their values. So you need to be careful about the charts that you're using. Check out this one. Everybody loves a drop shadow on their title. Why not? Right? And why wouldn't you have a red and a red gradient? Of course you would, all the time, right? And notice again that the states in white, that's not missing data, that's just lower levels. Careful with the color. It's kind of like you don't know what to say when you see a graph like this. You just shake your head and move on to the next thing. Okay. Now, a lot of when it comes to data visualization, a lot of it is subjective, right? Like, Adam likes greens and I like blues, and that's fine, right? We can all probably agree that this is just garbage, right? There's like checks and hex and like checkerboards and everything, and like, notice this book was published in 2010, so it's not like he was using Excel 1987, right? Okay, and also that this graph in the original book it's a 6x9 book, so it's like 3 inches by 4 inches. So that's what you have. I mean, what can you can just sigh is really all you can do and move on with your day. Okay, nothing wrong with line charts. Line charts are great, right? Like I'm not one to propose crazy new graph types just because they look cool. So line charts are great for time series data. The thing is, when you plot a time series, you don't actually need to draw the line of the year on your graph. And you can omit that from your graph. You can't even begin to start with this map of going back and forth, right? Like there's a little bit of things in data visualization where we want people to get the story right away, but we also want a second layer where they go in and investigate it, right? You're really not going to do either of those with this. You're just going to move on to the next thing. Pac-Man pie charts, of course, why not? Pie chart UFOs taking over the world, of course, why not? Okay, so then slides. So I'm guessing many people here spend a lot of time giving presentations. In general, stop doing stuff like this, where you put every single bit of text that you have. I mean, I don't know how many like researchers are in the room, but if you've gone to any academic conferences, what most people do is they'll take that reference page at the end and they'll just put that into bullet points and just give you this lovely list of citations. And then they'll talk about like one person and then they'll move on. But why is all this here? It's all just clutter. Like stuff like this, like actual photographs from slides that are impossible to read, impossible to see, and as you as the audience read them, you stop paying attention to the speaker. We all think we're good multitaskers. We're all very bad multitaskers. Adam's about to go onto Twitter, but he's going to stop listening to me while he does it, right? He's going to take a picture, right? But that's what happens. We're not good multitaskers, okay? Stuff like this, terrible data visualization like this with the break right there in 2000, of course. Stuff that's just, right, just stuff that means this is an actual slide. Someone actually thought that this was good to put in front of people, of human beings with eyeballs, that this would be worth showing. Okay, So 3 data viz strategies I like to follow. First is to show the data. This is why people are reading your blog post, they're looking at your visualization, they're reading your report. They want to learn something from the data. This is an interactive map from Brandon Martin Anderson. This has, from the census, this has a point for every person in the United States. And what I love about this map is that all that's here is data. That's it. There's no state boundaries, country borders, there's no lakes, there's no rivers, there's no city markers, there's nothing. You only recognize it's the shape of the United States because that's where people live. Now, this doesn't mean we need to show all the data all the time, but too many of us put too much stuff on our charts, on our graphs, that just sort of distract from our audience's attention and ability to see the story we're trying to tell them. So the second guideline is to reduce the clutter. Get rid of the junk stuff back here, the beehiving thing, the 3D, the grid lines, the tick marks, all that stuff that makes it harder to actually show the data. And then third, to integrate the graphics and the text. For most people, this very simply means taking those legends that sit off to the side or the top of your graph, completely disconnected from the content, and moving them onto the graph itself. And then once we've accomplished that, that's a low-hanging fruit. Once we've accomplished that, we can move on to do more things like this. This is a bubble plot from the Washington Post. We can start to add annotation. We can start to add stories to the graph itself. Remember to think about your audience. The average Washington Post reader probably has no idea what a bubble plot's actually telling them. I'm going to talk about some more examples of this in a little bit. All right, presentation strategies. I also have 3. First one is to visualize your content. As Medina said, we are more likely to remember and recall information if it is presented to us visually rather than through text, through letters, through words. Present things visually. Second, unify. Unify the content across your presentation. If you're going to use black and white photographs, use black and white photographs throughout. Only use color to emphasize. And unify what you show on the screen with what you say. Not everything you say needs to show up on the screen. So unify the two together. The slides are there to support you as the speaker, not to replace you as the speaker. If the slides are there to replace you as the speaker, that's what we call a report. That's what we call a PDF that you hand to someone and they go read it on the Metro ride home. The third thing is probably the most important thing, and applies to both presentations and to data visualization, is to focus. Focus your audience's attention where you want it at all times. Have one goal for every slide. Have one goal for your presentation. Guide them through your presentation one point at a time so that they follow you and they're not reading the slide while you're talking about something. Okay, so here we go. So some things to stop doing. Stop distracting attention. Here's a series of graphs from the Journal of Analysis, Policy, and Management. The authors are plotting the coefficient results from a model that's looking at the relationship between the unemployment rate and food stamp participation, the SNAP program. And when you look at this graph, your eye is immediately drawn to the thickest, darkest line on this graph, which is the zero-axis line, which is not an important line. Okay, and the most important line are those 4 coefficient lines. We have a bunch of tick marks. We have 4 y-axis labels. We have 28 different percentage signs. We have these abbreviations here, W, E, and SS. No idea what they stand for. In the journal, you'd think they would be nice enough to their reader to at least spell them out below the graph. Nope. You've got to go 15 pages earlier to figure out what SS stands for. And then, of course, they leave out some data markers here. This one's left out, that one's left out, because, well, who would want to expand the y-axis when you don't have to? So we can apply all those principles I just talked about, showing the data, reducing the clutter, integrating the graphics and the text, doing something like this. I've lightened all the grid lines except for the zero-axis line, which I've left a little bit darker for the series that drop below 0. I've spelled out each of those abbreviations, and I moved the word caseloads, which appeared 4 times in the original, into the title. And I've gotten rid of 2 sets of y-axis labels and 2 sets of x-axis labels because the graphs are aligned horizontally and vertically. Horizontally and vertically. And most importantly, I made the darkest, thickest line the coefficient line. I'm showing the data. That's why people are reading this chart. They want to learn something from the Now, in your mind, rank the pie chart from largest slice to smallest slice. Bless. Okay? I'll show you a bar chart. Pretty close. A lot of people are like, that was close enough. It's okay. But I bet you were all right when I show it to you this way. Because we're better able to discern those quantities when they're shown by the lengths of the bars or the heights of the columns. All right, stop using 3D. There's some debate about pie charts. There's really no debate about 3D. Don't use it, okay? And here I'm in the world where if I don't have a third variable. If you have a third variable, then we can have a separate discussion. Even though I would usually recommend to avoid that because people don't do it well, okay? So avoid 3D. Okay, so here's a pie chart. 3 slices. Every slice takes up 1/3 of the page of the screen. I take that pie chart and I rotate it just a bit. That front slice now takes up a higher proportion of the page of the screen. So this is not a knock on pie charts. This is just pointing out that by rotating the graph, you are distorting the way we perceive the data. That front slice looks like it takes up a higher proportion of the pie than it does in the 2D representation. And we see this all the time. So here is a 3D column chart from the USDA, who, by the way, loves 3D. Did a great exploding 3D pie chart yesterday. Anyone here from the USDA? No? Okay. Yeah? Awesome. We can talk later. Okay, so USDA 3D column chart. First thing about this column chart you have to do is you have to ignore the y-axis label, which is millions/billions. Just sort of just like, okay, sure. Okay. And then you can look at that certification bar on the far left. Okay, if you look at that certification bar, it's labeled 1833. And yet, no part of that column actually touches the 1800 grid line. So why is that? Because what the software does is it uses a perspective rendering device. So if you sort of bend all the way down and like imagine a plane that runs along the top of that column, it intersects this brown, orange, yellow background thing at 1833. But when we look at it, it looks like it's less than 1800. Similarly, this is from a social policy journal, Cityscape. People love cityscapes. Why not? And why would you have a checkerboard when you could use anything? Okay, so any guesses as to the share of never married white non-Hispanics? Well, it might be 0. I don't know. It's just less than this other group, which I don't know what that is because it's in 3D, so I have no idea. So let's stop using maps. Okay? I would say probably 99 of 100 maps you see from data visualization folks are just population density maps. Okay? So here's a map. You may have seen this. Came out a year or 2 ago. This is on economic activity in the United States, split in half. Okay, what do the orange areas remind you of? Cities. Why is there a lot of economic activity in cities? Because that's where people live. Okay, so all that is a population density map. That's all it is. Okay, how about this one? This is distance to the nearest McDonald's. And someone might say, wow, McDonald's isn't doing very well out west. No, people don't live there. That's all. not be familiar with this chart type. So notice what the times does. They add 4 diagonal lines. The first one, the 45-degree line, nice big bold black line, says equal wages. So now someone reads it says, okay, if a point lies on that line, it's equal wages. Now what happens if I'm off that line? Well, the times gives you 3 other lines. Labeled women earn 10% less than men, 20% less than men, 30% less than men. So now that average New York Times reader, maybe never seen a scatter plot before, comes to this graph, and because of that very simple annotation, understands or can understand what's going on. Similarly, this is a bubble plot from the LA Times. Okay, we've got violent crime along the x-axis, property crime along the y-axis. This is all cities in California. Notice what they've done. They've divided into quadrants, and they've labeled each one. Oh, the top right is worse because it says worse in big letters. The bottom left says it's better because it says better in big letters. And I've got all this extra text off to the side, not distracting from the data, telling me a little story right here. More violent property crime in nice, bold letters. And then a sentence below that that explains the story. Again, the casual LA Times reader has never seen a chart like this before. So you need to think about your user, thinking about your audience, and don't make them figure it out. Okay, now, I added this in here to this talk because it's a Tableau user group, and I'm sort of developing my own philosophy here that the interactivity for the sake of interactivity is a waste of everyone's time. Okay, so here's the BLS, likes to put out interactive charts. People do this sort of stuff all the time. It's a line chart. This line goes up, this line goes down, and then they put it into high charts, or to Tableau, or to D3, or whatever. Pick your multitude of a billion tools we now have, right? And they give us interactivity. Why? How does the interactivity help your reader understand? This is a project from the New York Times last year that people love. 255 charts on the economy. I should call Connor.
Trying to figure out the hangout.
Oh, okay. So then I
Hold on, sorry.
watch the video.
Okay.
We good? We're better. Okay, this was a very popular chart. 255 graphs. Watch what happens when I click on one of these lines. I get this little pop-up. How does that interactivity actually? That doesn't actually help. Use interactivity when it matters. Here's another one. This is from Mathematica, right? Like, first off, it's a map. You already know my feelings on maps. Secondly, you click on the map and it zooms in and it gives you a table. So not particularly useful. So at Malopier, which is a conference in Spain a few weeks ago, Archie Say from the New York Times passed out 3 rules of interactive design, and I can't agree more with these. So first, if you make the reader click or do anything other than scroll, something spectacular has to happen. Okay? So, you know, you're all like 100% Tableau users. So if you're making people do something, they better be doing it for a reason. Also, people don't click. Let's just put that right out there. They just don't click, okay? 2, if you make a tooltip or a rollover, assume no one's gonna read it, right? I'm like, I can't agree with that more. People are not gonna click. They may scroll, they're not gonna click. And third, if you're worried, if you're deciding whether to make something interactive, you know, and you're going to try to get it on mobile and tablets and desktops, that stuff's all really expensive. Like, that's expensive to get people to do that and to think about that and to design for that. So let's just take interactivity off the shelf when it's not actually helping people. Right? A static graph is fine. If you have a line chart with 3 lines and you want to show that these 3 things are going up, and being able to click on the line and get the data to show up doesn't help anyone, right? Give them a link to the data. Okay. All right, let me shift a little bit to making bad slides. Okay, so slides like this, Census Bureau, slides like this, Congressional Budget Office, slides like this from the USDA, again, USDA. USDA, I'm not picking on you, by the way, I'm just saying you guys show up a lot. It's like the obsession with clip art and 3D at the USDA makes me wonder what's in the water. Okay, USDA. So, of course, an agenda slide. Like, don't spend 5 minutes talking about what you're going to be talking about. Just talk about it. And we know you're going to have an introduction. We know you're going to have questions and answers. Just get to it. When you put a lot of text on your slide, people do one main thing. They read the slide. And what don't they do while they're reading the slide? Yeah, they don't listen to you, okay? So we need to get that stuff off the slides. So I like to do something I call layering. Very, very simple approach, right? I don't know what's going to happen there. So imagine this slide has all the text on it that it's supposed to have. So 3 full bullet points. And when you have all these bullet points, you start reading them. So instead of having all the text, layer the graph one at a time. So here, that's what the original bullet point was, here's a bullet point. And now I, as a presenter, can either be quiet for a moment and let you read it, or I can read it aloud, which is also super annoying. But whatever I do, I can now talk about this. And now you're not going to actually go bother, there's nothing else for you to read, so you have to turn your attention back to me. Okay? Then I can add the second bullet point and gray out the first. And then I can add the third bullet point and gray out the first, gray out the second. Now my wife's in healthcare. At her hospital, they have what are called in-services. So they have someone on the staff or an expert come in from outside, and they'll give a lunchtime talk. So imagine, if you will, you're in the physical therapy gym at a hospital, and it's a lunchtime seminar. It's an hour. You have, in addition to listening to the speaker, you have to check your email, you have to eat your lunch, and you have to finish the documentation from your patients from the morning and set up your schedule for the afternoon. That's what you have to do in that hour. Because at 1 o'clock, you've got to go see your next patient. So what happens is that the speaker comes in, puts up a slide with all the text, 50 heads go up, read the slide, 50 heads go right back down to doing what they were doing. So my wife has sort of drank the Kool-Aid a little bit, and so she doesn't put text on her slides. So what happens is she works on stroke care. So she puts a picture of a brain on the screen, 50 heads go up, and they have to keep up. Because if you don't pay attention to what the speaker is saying when that picture of the brain's up there, you're not going to get much out of it. A slide is not a document. A presentation is not a report. Those are 2 fundamentally different things, 2 fundamentally different ways to communicate. So we can also take, applying that idea of visualizing, we can take that text and turn it into graphs. You are much more likely to remember this graph, and this graph when I present it to you visually as opposed to a set of bullet points. So use good techniques when it comes to data visualization. Show the data, reduce the clutter, integrate the text onto the graph itself. As we move into a world in which we move further and further away from PDFs into an HTML world, the thing that people are going to share are going to be the images. So if you can add annotation onto the graph, both to explain the content and how to read it when appropriate, that's just going to be shared. And so you don't need people to actually have to worry about adding all the text and adding their own summaries of your work, because it's all contained in that image. Visualize your content, unify what you say and what you show, and focus your audience's attention where you want it at all times. Do I have time for a show?
Sure.
How much more time do I have?
Like, what time is it? Oh, you're still good.
We're still good? Awesome. Okay, I'm going to totally shift gears. Okay, so I'm going to shift gears for like 7 more minutes. So, yes, Alex.
Is it totally shifting?
Yeah.
What about animation? You talked about like a lot of interactivity being noise and frills.
Yeah, animation on slides or in...
Yeah, like, say a motion chart or line chart that fails over time. I mean, when's it good, when's it bad? So
I think, so the question was, when is animation good in a presentation or in a graph that's online, right? If you have a line chart. So I would say if you're a PowerPoint user, basically like everything except appear and disappear should basically, for the most part, be ignored, right? Like lines, really. Star swipe, there's a great Homer Simpson quote where Lisa says, "Dad, you don't need a star swipe for everything." He's like, "Why eat ground beef when you can have steak?" So, again, I would just say, if the animation, so just imagine simply like Alex just said, imagine a line chart where you reveal the line changing over time, right? Or you've all, hopefully, have all seen the Hans Rosling TED Talk, right? That's an animated bubble chart, right? If the animation helps you focus your audience's attention where you want it, then it's a good use of animation. So if moving that line, having that line reveal over time is helpful to have them understanding the content, then it's a useful case. If you're just doing it because it looks cool or it looks pretty, then you're just making 3D exploding pie charts, right? That's not what we're trying to do. that helped. Any other questions before I sort of move on? Okay. So what I want to do is I want to talk about a little project I did at the end of 2014. That it was a project I undertook because I was trying to get my head around all the different types of graphs that are out there. Because one of the challenges when we are working with data and trying to visualize data is that data don't map one-to-one to a graph. Like, it would be great if it did, but that's just not the way the world is, right? You can use a column chart to compare categories, right? You can also use a column chart to show changes over time, right? So one of the challenges that we have is, well, how do we choose a graph for the data type? So I went through with a friend of mine, and we designed a project called the graphic continuum. This is, I'll give a couple of these away. It's just, well, this is like the card version. We actually started with a poster, a big poster that had more of the interactions between the two, so column chart here and there. The problem is people were like, I don't have an office wall to put a huge poster. So we made this desktop version. And the whole purpose here, again, for people who have this, is more of a thought starter. So, oh, I have data here. I have some time series data. How can I present time series data? We have 6 different categories on this: distribution, time, categories, relationships, part to whole, and then geospatial. So so what I want to try to do is tell you about this project using a story. So the space of graphs that are out there, the choices that we have available to us, that's a very complex space. It's a very non-linear space. So instead of me trying to sit down and walk you through all these, what I want to do is tell you a story about it. And the story I'm going to use is I'm going to borrow from my kids' library collection. So if you have kids, you may be familiar with these books. If you give a moose a muffin, if you give a pig a pancake, if you give a mouse a cookie, you wouldn't have kids? Okay, good. If you don't have kids, you should still read these books because they're super fun. And what they all use what's either called a cascading storytelling device or a circular tail device. So what happens is, in this book, the kid gives a moose a muffin, and the moose eats another muffin, another muffin, another muffin, until they're out of muffins. So then they're going to go to the store so they can get more muffin mix to make more muffins. Well, he puts on his jacket, there's a hole in the muffin in the jacket, then they have to get needle and thread, and they start making it, then they decide to make sock puppets, and it circulates, and it sort of cascades all the way through. So what I want to do is try to use this circular tail device to tell you about this nonlinear complex space of the graphic continuum of all these different types of graphs. But of course, I'm not going to use a moose and a muffin for this particular story, not going to be very relevant. So I'm going to use my own version of this story. So this is again my approach of trying to tell you about this sort of complex space in a linear narrative presentation like this. So if you give a nerd a number, he might want a table to go with it, to which he can add another number and another number, but we'll first focus on that one number. And he can take that number and he can plot it in an XY space, to which he can add another point and even more points. And this might remind him of other graphic types he could use. It might remind him of a stacked area chart, or a normalized area chart, or even a paired column chart, or maybe a stacked column chart. And you can rotate that chart, that graph, 90 degrees to create a paired bar chart or even a stacked bar chart. And you can go back to that line chart, add more and more data. And this might remind him that he could break these graphs up, right? Add more and more data. He could create spark lines. Or he could focus just on the endpoints of that graph to create a slope chart. And you can take the slope chart and you can rotate it 90 degrees to create a dot plot. And all this uncertainty about how we map data to graphs, to visualizations, may lead him to think about uncertainty, which may lead him to think about fan chart or a Boston whisker plot. And if he took that line chart and added a secondary y-axis, this may lead him to think about correlations, which of course will lead him to start thinking about scatter plot, to which he can add a third variable to create a bubble plot, or the unfortunate 3D bubble plot. And you can combine the bubbles with the lines from earlier to create a parallel coordinates plot. And all these graphic types and all these relationships may lead him to start thinking about other shapes, may lead him to think about a radar chart, or might lead him to think about connecting the points over time, so to combine the correlations and the time to create a connected scatter plot. And these connections may lead him to think about other chart types, may lead him to think about a network diagram, or a force-directed layout, or a hive chart. And the curves in the hive chart may lead him to think about the chord diagram, and the arcs in the chord diagram may lead him to think about an arc chart. And the arc chart he could combine with time to create a sequential arc chart in which time is plotted from point A to point B, point B to point C, and point A to point C. And this very simply may lead him to think about time. May lead him to think about a flow chart, tree diagram, or very simply a timeline, which again, he could rotate 90 degrees to create a Gantt chart. Or very simply to create a heat map, calendar, something we're familiar with. And all of these may lead him to think about other shapes he could use. Might lead him to think about a nightingale to combine the circles and the time. But of course, a nightingale is just a circle that's been exploded in all different directions. And he could rein that back in, and that may lead him to think about a pie chart. Or the unfortunate 3D pie chart. Or the truly unfortunate 3D exploding pie chart. But he could also punch a hole in the middle of it. He could blow it up again. He could divide it in half. But all that's just a variation on the circle. And this may lead him to think about other shapes he could use. Might lead him to think about squares. May lead him to think about a tree map, which again, he could blow it up and create a square cloud, or stack them on top of each other to create a unit chart. And this may lead him to think about other shapes he could use. May lead him to think about an isotype. And this may lead him to think about high frequency data, what we have when we have a lot of data. This may lead him to think about a heat map, or a contour map, or the truly unfortunate 3D contour map. And this may lead him to just simply think about maps, to which he could add circles, or squares, or lines. And the connections formed by the lines on the map may lead him to think about a particular point on the map, where he's currently standing, speaking to folks about data visualization and communicating information. And you can take that point and you can plot it in an XY space. And so if you were to give a nerd a graph, you might want a number to go with it. Okay, so that's the graphic continuum story. That's all I have.
Any questions before Jonathan?
Okay, so again, I would just encourage you a few things. Primarily think about your audience, right? Think about who you're communicating with. If you're, working in your office and you're going to have a meeting with 3 other people sitting down, don't necessarily worry about the PowerPoint issues. If you're going to be presenting to a room of 100 people, that's when you need to start thinking about visualizing and focusing your information. And so I'll just leave it at that. So we have a few more things to give away. Yes.
What is your book?
Good question. The book is supposed to come out right at the end of October, early November. I have now the cover art for my publishers. All right, getting there. Copy editing. It's called. What's it called? No, I do have a name for it. It's called Better Presentations, a guide for researchers, scholars, and wonks. We have some goodies to give away. Any other questions? Yeah.
So, okay, you talked about maps and
Yeah.
kind of the good and the bad of maps.
Yeah.
So
Mostly the bad. I talk mostly about the bad, but okay, yeah.
Yeah. So I actually really love it.
Okay.
But, so I'm just kind of curious what your thoughts are when you're dealing with, let's say, international data, and you want to show, let's say you want to show the concentration or the amount of pneumonia rates.
Just hypothetically speaking.
Hypothetically
Sure.
speaking.
Okay.
And you want to show that in different countries over a span of time, whether it be months or years, right?
Right.
And let's say that is hypothetically helpful to people, right?
Right.
So, I mean, just kind of referring to that small example, what do you think about
Okay.
potential effectiveness or maybe increasing the effectiveness?
So for folks in the cheap seats in the back, question was, if I have international data that's changing over time, is it useful to make a map of those data and allow it to change or animate over time? Well, that's right. So I would say if there is a geographic story there, then it may be of particular interest. I will note that one of the main things that people don't like about maps is that the geography distorts our perception of the data. So just imagine the United States, for example. California is a really big state, right? It looks a lot bigger when you look at it. Rhode Island may be a higher value of that data, but it may look smaller. Another good example is Alaska. Tableau here?
Yeah, that sounds good.
All right. So I have 2 of these to give away. So I need 2 volunteers to start. 1, 2. Okay, these are for you. See, you all just didn't volunteer, so you don't get one. There you go. Okay, and Tableau here, I have 1 more graph for people to guess the name. This is fun. What are we doing, t-shirt?
Sure.
All right, t-shirt. All right. Ready? First one to guess the name of the creator of this visualization wins a Tableau t-shirt. Yeah, right there. Come on, you should all know that Brittany made this. Man. Come on. All right, I don't have any other.
Okay.
All right.
Awesome.
Great. Thanks, everybody.
All right. Next, we have Nayeem Ahmed, who is an analytics consultant at Interworks, where he specializes in strategy and implementation of BI solutions, and he believes that collaboration is the key to success and has extensive work with government agencies. Also, in between presentations, feel free to use the restroom, get drinks, other food.
Oh, I didn't see that. Yeah.
Let me make sure I'm great. That's not my presentation, by the way. Yeah. Got a new laptop, so I just gotta figure out how to stand here. Okay. Okay, thank you, everyone. It's good to be here. My name is Nayeem Ahmed, and I work for a company called Interworks. Just a quick minute on myself, and I'll talk about the company, then we'll jump right into the presentation. And if it's okay, I'm going to stand close to the laptop. I have a lot of different websites I want to bring up and hopefully show you more than I have on slides. So I work for Interworks, like I said. I'm based out of the DC area, so it's kind of nice to be local and presenting locally and see some other familiar faces as well. I've been doing BI for a long time. I've used different kinds of tools, all kinds of tools, I should say, and what I've been doing lately is really sort of helping Tableau implementations at more the enterprise type organizations where, they typically have a lot of people that are building content, but it's also about the, how do you really make it work for the enterprise and so people can see what you're building. A little bit about Interworks itself, who we are. So we've been Tableau Partner of the Year every year. They've awarded the, I guess the award, I should say. And essentially we're sort of on the East Coast, West Coast, Midwest. We also have an office right outside of London that services a lot of the EU countries as well. And we wrote the book. I don't know if you have Tableau Your Data. We have a second edition of the book that's out there as well. And kind of like I said, we really do just all kinds of support with Tableau consulting. Obviously, you're familiar with the drive methodology, which is really sort of speaking to how do you drive adoption within an organization. We do some of that work. We do a lot of training. In fact, when you're asking for training through Tableau, there's a good chance that one of our consultants will be showing up to really conduct a class. And we have done a lot of implementation for all kinds of clients around the nation. And obviously, in addition to sort of the dashboarding, we do server support and we do a lot of integration support as well. So we're going to sort of, I wish I had talked to John last week before I came here, so I would have better visualizations to present. But thankfully, we're going to talk about something a little bit different. So it's not about best visualizations. It's a JavaScript API and Tableau. And I don't know how many of you have used this, but the presentation is meant to really cover the basics, meaning tell you what it is, show you some use cases for how it's being used, and hopefully there is enough knowledge here that you can take back. And if you haven't experimented with it, this would be a great place to start. So first thing first, I'd like to give you sort of the big picture. And I think the key to note here is you're not doing JavaScript API integration on your desktop. You really need the pieces that are in the slide here. You have your traditional Tableau environment where someone is doing a lot of the content development and throwing it up on a server or throwing it on online. And then you need a web server, and the web server is where the integration of the interaction will happen. And on the left side, your sort of these are sort of the preferred sort of tools for interaction on the customer side. And that's really the story here. Not everyone has desktop. Not everyone likes to go to server. People get very comfortable in the environments they're in. And if you're like me, the first thing I do when I come to work is fire up my inbox and I open up a web browser, and I usually have my landing page, and everyone has a favorites button. So it'd be fantastic, that if I didn't have to go anywhere else, but I could stay on my web page, I could see my visualization, do all the interaction I need from that one spot. And that's kind of the idea behind developing solutions with JavaScript API. So the way this is set up is I'm going to walk you through a few use cases, three, and we'll go from sort of the more simple example, and then we'll walk you through some of the some more advanced where, again, I think it's about giving you enough ideas so you can go back and decide what solution makes sense for you. So the first one, and this is where I need to jump to a link, so forgive me, I just have to get to my web page. Okay, so this is a visualization on, you can see it, we've taken some survey data, and then I think, the question is, what do you consider polite or not polite when you're traveling, right? And let's talk about the solution a little bit. So I think that the pieces you need for this, again, you have someone that's building content and desktop, publishing it onto a server. And what we've done is we've embedded the dashboard into a custom portal solution. And the function here is, this is a live dashboard. So, you've got 4 sets of filters. This information, again, at the very bottom, this is sort of the answer to the question, what do you think is not polite? Is it rude to recline your seat? This one's got, is it okay to talk to a stranger? Is it okay or not okay? Or is it rude to bring unruly children on the plane? And I think if it were me, I would have maybe 20 more questions here for sure. But anyway, the idea is, you are interacting with the dashboard. And what this is doing is, again, you're on your portal environment. You will take the filters and you will pass the filters on to Tableau from your portal environment. And really the only other feature here, and I've given the presentation to Brittany, if you wanted to go play with this and come to your own conclusions about the data, you're welcome to. What I've noticed that, sort of just very quickly is there is one specific segment of the population, I won't say who, thinks everything's rude on a plane. So good luck if you're sitting next to one of them. Okay, the other thing we've allowed here to do is the ability to download the visualization. And these are, again, the same features you would have on Tableau server. But again, the idea is, if you're in a portal environment, that's where you want to stay. Okay? All right, so let's move on to the second use case. And this one is a little bit more advanced. And what's different about this one is, and I think, again, John talked about some of the graphics not to do, but I'm going to talk about some D3 visualization. And for those of you, D3 happens to be sort of a class of charts that you get in Java, and you get to do things that you don't get to do in Tableau, because in Tableau, when you say show me, you typically have sort of the best practices graphs that will show up, but sometimes you need something different. And this is a good example of where you can kind of integrate a Tableau visualization and then take advantage of some of the other technologies that are out there. So what I've done here, again, on the Tableau side, you're still building a dashboard, you're still publishing it to server. And what we've done here is we've embedded the dashboard into a custom portal. In addition, what we've done here is developed a chart in D3, and hopefully you can see that okay. Sorry, were you able to see the last one? I'm sorry.
Yeah.
Yeah? Okay. This is not coming up on the screen. Yeah, yep, you're right. That's it. Let's see. That's not how I do it. Okay. Now. Sorry about that. Okay. So this is the visualization, and this is sort of the content here is we've taken public information on a lot of the government agencies and their budgets. And on the right-hand side, what you have is this is your Tableau Viz. It takes the trend for the budget, and it's giving you sort of the budgets by the biggest accounts that are out there. But sort of the takeaway here is, again, you are in a custom portal environment. You've had the ability to build one of these really nice-looking tree charts. If you pick one of the organizations, what this will do is it will drive you to all the departments that are under. And then you can certainly click on one of the departments. But the nice thing is, this one has no data. This will bring back, render that Tableau visualization on the right-hand side. So you can really drive down to the budget information that you're looking for. But like I said, I think it's sort of another way of solutioning something where your users are staying within your portal environment and obviously can leverage the technology that you have within the portal as well as Tableau. All right. And the last one, let me walk you through this one. This is a little bit more advanced. What we've done here is we wanted to see what Java API scripting would look like with the web application. And in our case, the web application has the ability to take some input from the user. And we've taken some information on a sales model, or retail model. And the inputs are then run into sort of a more sophisticated predicting software we're using in this case. So the architecture is you're going to the web application, you're giving it some input. The data is passed to R, which is hosted on AWS server for us. And we're writing the results into a Postgres database. And what we're doing with Tableau is we're just saying, Tableau, go ahead and point to the Postgres database so you can render the visualization. And I know it's a mouthful, and I know this is not something you do just overnight, but if you get to a situation where you have to build a solution that has to take into account sort of the current ecosystem that exists in the organization, and people are used to doing it a certain way, this will be, again, another option for you to do the integration out there. So I'm going to go back to the slide here. And we have a data sciences portal. Some of this may take a little bit, but let me see if I can. I'll click on it, and I've actually brought the results back onto a different screen because I know it takes a little bit to run the forecasting model. In this case, sorry, this is a different example. What we've done is we've taken sort of applicant information, and a lot of this is mock data, but we've given you the ability to say, if you're thinking about hiring a candidate, wouldn't it be nice to see if that candidate also matches an existing profile of the individual we have within the organization. So this is the web application where you get to sort of put in some information. If it's asking for the years of experience, let's just pick 5. Let's assume this person has a master's degree, and then it'll ask you a few other variables, what kind of skills they have. You can see they have SQL, they may have HTML, maybe they do some Perl. And then you also have the ability to do your own rating based on your interview. And we say, okay, well, you talked to the person, they're very good at predictive analytics, and it's a scale from 1 to 5. Let's say they're about a little bit slightly above average. How are they on desktop skills? You might want to put it 2 maybe. Do they have any DBA type skills? Maybe it's a 2. And how are they on presentation? Maybe really not very good. And then when you submit it, this is where that integration, again, is happening, where the data is going out to Amazon Web Services, it's going to the predictive model, and it's going to write the results into the Postgres database. And Tableau, the dashboards that we built, are pointing to the Postgres database so you can render the results back in the graph. And this takes a little bit of time, so what I've done is I've gone ahead and kind of shown you what the results look like. And it's not the best graph, again, it's slightly compressed up there. But the idea, you get it. I think it tells you sort of the where this individual falls in sort of in the pool of skills you have. And it's giving you this, again, D3 chart at the bottom. And here, I think the color coding is what signifies the sort of the similar personalities within the organizational skill set. All right, so I've said a lot. Did that make sense? Are there any, again, this is more of maybe, how to build a solution type conversation, not necessarily how to do best practices on the biz, but in summary, I think, I'll go back to this slide again. The takeaways are Java API scripting is actually there to be helpful, and the actual coding isn't tough. And I do coding. I'm not the best Java coder, but I've looked at it. They've kept it very simple. In this context, what Java will do again will translate the Tableau language to a web language, so it knows how to interact and connect the dots. And then you decide what type of features you want to add to the web page or to your portal environment or the web application you have. And it could be as simple as putting some filters in place to actually doing some pretty creative type visualization using some other technologies as well. And I don't have anything to give away, so I think we're going to stop here.
Any questions?
Go ahead, Marie.
I didn't know that you could do that. You could integrate D3 and Tableau. So if I wanted to do that this afternoon when I go home, how would I learn how to do that?
Good question. So d3.js.org, I think, is the website you want to go to just to get some examples of the type of chart you may want to play with. And then I think they also give you samples of the code. So you take the code, and then I think this is where my knowledge stops as far as when you want to put it into your portal environment. It's really two different portals and how you decide you want to put the D3 chart as well as the Tableau dashboard. And And the actual syntax for the filters is on there was a great community on Tableau. I want to say it's Tableau Java API, or if you just Google Java API script in Tableau, you'll get to it.
Awesome, thank you.
Okay.
All right, next we have Marie Whittaker, and she visualizes economic data as part of the economic intelligence team within DC's Office of the Deputy Mayor for Planning and Economic Development. She uses Tableau and other tools to look at the district's data and is open to the public and builds database narratives of DC's economy for policymakers.
Yes, that doesn't work. All right. Sorry, George, that noise. Can everyone hear me? Yes. Yes. That sounds good, yes. I'm Marie Whittaker. I'm very happy to be here among the great presenters, and thank you to Brittany and to Chief and to the DC Tableau Users Group for having me. I'm going to talk a bit today about dashboarding. Probably if you're using Tableau, you're creating dashboards, and how we inject data into policy decision making in the district government. So I work at DMPED, which is a really obscure acronym, so you know it's the government. It stands for the Deputy Mayor for Planning and Economic Development. And even if you've never heard the acronym, you're probably, if you're from the DC area, familiar with some of our projects. You can see here Walter Reed, the Gateway Pavilion at St. Elizabeth's, the Wharf, City Center, Howard Theater, DC United Stadium, it's coming to Pleasant Point. My office does real estate disposition and development, so when the district has surplus land that we want to transfer over to private use for more efficient use or for actually better uses, that's what my office does. We create affordable housing by negotiating into our real estate development deals additional units of affordable housing beyond what the private market might support. We grow local businesses by doing grant programs, by providing technical assistance. We attract businesses and jobs to locate in DC, and we do all this kind of bottom line to increase the tax base for the DC government so that DC can continue to provide public services for our growing city, our rapidly growing city, I'll say, and to pay for things that make DC a vibrant place to live. And for our office, for the policymakers within DMPED and within the DC government more broadly, economic data is the context that is underlying all of our decision making, all of our policies. And my team within DMPED is called the Economic Intelligence Team. I think we have a few other people here from the DMPED EI team. There's Joy. Hi, Joy. Joy Witt is also working on economic intelligence. And I didn't come up with the name, but I have to say I really am fond of introducing myself as Marie Whittaker, Economic Intelligence. So what I'm going to talk about today is how we're using data in DMPED. First, I'll talk about dashboards and when and why they're appropriate. I'll take a little detour and talk through a few examples of how we're actually using data in real-life scenarios. And then I'll do a demo-ish type thing on our open data dashboard, which we just launched earlier this year online. So first, dashboards. I'm going to take a step back here and talk about why monitor key economic indicators. I used to work at, before I was a dentist, I used to work at the Consumer Financial Protection Bureau, which I think is a good example of how data is also being used in the public sector. Some of you might remember in 2008, there was this giant financial crisis. And afterwards, everyone was kind of like, oh, we didn't see that coming. Don't know why. Well, the CFPB came into existence as a result of the financial crisis, and I was on a team that was helping stand up the mortgage market monitoring function. And essentially, we were looking at our economic indicators to try to predict or detect the next mortgage market meltdown. So that's one example of how data is super helpful in a dashboard format to create and inform economic policy. In DC, obviously we're looking at things that are a bit less acute than a mortgage meltdown, but we're looking at things to try to tell the story about what's good about living in DC through data, through quantitative metrics, and then what's troubling us about DC's economy so we can get in front of things that might be bad down the road and try to make policy that will improve lives of residents. And then I want to also talk about what, in the policy world, what is data competing with? When I'm talking to policymakers, they might have assumptions based on a lot of other inputs, a lot of other, I guess, data inputs besides actual data that they are making their mind up about things based on. One of my favorite examples here is how many of you in the last month have read an article about millennials? It's almost everybody. Maybe you're avoiding them, like I am. There are so many articles out there about how millennials love cities. They are moving to cities in droves. Either that or they're living in their parents' basements. They love artisanal honey, and they ride bikes everywhere. So if you are on Twitter or reading the paper, you are probably making your mind up about millennials based on all of these stories, this runaway train of stories about millennials. But actually what the data is telling us, and this is an example of good data journalism, I think here, this one's from 538, is that actually millennials, and we're here looking at only adults ages 25 to 34, whereas millennials are around 18 to 34, it uses the more mobile group. They're actually not moving into cities at any notable pace. They're slightly less as a proportion are living in urban areas in 2013 compared to 2000. But what we are seeing is that people with bachelor's degrees are moving to cities. And I don't think it's a coincidence that people in high places in the policymaking world, generally those are people with bachelor's degrees. Their friends probably have bachelor's degrees. They're seeing that happening around their personal circles, and then they're reading these articles about millennials, and they're saying, yep, they're confirmation biasing that story. And so I think what we can do with data is to really gut check what kind of other inputs are coming in and creating a opinion environment that policymakers have. And in DC, actually, to shift away from the national data, in DC, we are gaining millennials, but our population in general is going up. And actually, more recently, the growth rate of people ages 20 to 34 has lagged behind the growth rate of the population of DC generally. So we're not becoming an especially millennial-heavy city. We might have been a few years ago, but not really anymore. And so if you're a policymaker trying to make rules or regulations or decisions about what the built environment of DC is going to look like for the next year, 10 years, 30 years, and you have a flawed vision of who is moving to DC, what their living preferences are, you might make decisions that are not right for the population. So one answer here for this kind of get information out, get the correct information out, is a dashboard. since data is competing with anecdotal evidence, since it's competing with personal observations, since good data is competing with bad data, honestly, we've put together internally and have had a curated dashboard of just a few key economic indicators to do two things. One, to spread a baseline level of knowledge about what does DC look like. How many people live in DC right now? Anyone know?
600,000.
617,000, just about. Get bigger. What's the unemployment rate in DC right now? Anyone know? 6.5. So that kind of thing. What are the key numbers that you need to know to set that baseline level of knowledge? And then, since it's a dashboard, the focus of the dashboard, in my opinion, I think, should be make everything the same always so that you see what's changing. And I'm gonna take here, I think, a somewhat controversial position. How many of you work with people who prefer to digest things in words? Some of you, some hands there, lawyers. I work with lawyers. A lot of people aren't data nerds, honestly. And a lot of people who I want to have the correct data and trend information aren't data nerds. They're not going to look through this dashboard. So the position I'm going to take is that actually Tableau, for me, and dashboarding in generally, isn't a collaboration tool. It's really not. A lot of people like to talk about how, now I sent this Tableau dashboard to my manager and we have a better real-time look at what's happening in HR. That's not the case for us. Tableau is for me. It's for my team. It saves us time, since we've automated kind of the back-end process of getting data in and visualizing it. It saves us time that we can then use to do analysis, to tell the story, to figure out what are the 3 key things that I need to put into words this week to let all the people who are making policy in DC government know what's going on. So actually, these databases, I make them, if you're not talking to data nerds though, as John said earlier, assume nobody's gonna click on your hover. Assume nobody who's not a data nerd is gonna even look at your graphs. And that's the assumption I'm taking with our internal dashboard. Really, it's just a time-saving tool for me and the team. Next, I'm going to jump into a few little examples of how we're using data. Another benefit, I would say, of a dashboard, for me, another personal benefit, is that setting up a dashboard gave me this great product, this data library of everything that we use on a regular basis. It's ready to go, ready to jump into if we need to do a deeper dive, a deeper analysis, or if one of the indicators that we see in the dashboard has changed in a dramatic way and raises a question mark. We've kept everything simple in the dashboard so that when we need to answer more complicated questions, we do that analysis specifically. One example of that is the deputy mayor for planning and economic development said to me a few months ago, I heard someone say the other day that tourism is DC's biggest export. That sounds fantastic. Like, I would love to be able to say that when we're talking to companies to attract them into DC. Like, DC is doing great at tourism. Tourism spending is our biggest export here in DC. Is it true? Like, well, I don't know. Let's find out. So we looked into DC exports. Actually, yeah, tourism, if it's contributing $4.2 billion to DC's economy every year, it is bigger than most of the value of our exported commodities in DC. But DC doesn't really just export commodities. We're not really a manufacturing town. So we then looked at DC's GDP by industry to compare that industry of tourism to the other industries that are making gross domestic product or gross state product for DC, and found actually it's really dwarfed by the professional services industry here in DC. And if you assume, let's say that even a small proportion of the professional services, consulting, law firms, etc. in DC are exporting those services to somewhere outside of DC, which I think is a reasonable assumption, then no, actually, tourism is not DC's biggest import. So that was our answer. I said, please Deputy Mayor, don't say that. It's not true. You can talk about how DC is doing really well in tourism compared to other US cities. It's a big proportion of our GDP compared to other cities. New York is a bit higher, but we're doing pretty well there. But please don't say that it's DC's biggest export. Another way that I want to talk about how we're using novel data in the Deputy Mayor's office is using word data and text data to actually quantify for the first time community input. So as part of the process of surplusing and redeveloping district real estate, we go out and talk to the community, see what the priorities are, see what the considerations are for redeveloping a piece of land or an old vacant building, for example. And at those community meetings, there might be a series of meetings on different nights. We usually have small group tables where there are facilitators talking to different groups of people. And one project manager might come away from the meeting with a totally different impression of what community members want than another project manager who was at a different table or on a different night of the meeting. So we took all of the notes from some community meetings. Every table had a big whiteboard. We transcribed them. We wrote a little script that broke up that document into interested in a recreation center and walkable development. And that is something we can point to that's data-based, that isn't necessarily based on anecdote or impression or the loudest voice in the room at a community meeting. Just another visualization here of where we've grouped the terms, which, yes, is a bit manual, requires someone to go through, but is a lot easier in Tableau with the grouping function where you can see the list of all the words and start to group them together. And this is just a simple bar graph of what people would like to see in the space that we are putting up for redevelopment. So after that minor detour, I'm going to switch now back to dashboards and talk about our open data dashboard, which we launched earlier this year in January. So we recognized, yes, we have this with this infrastructure of a dashboard. Most of the data is actually public. The best economic data is from government agencies, so it's generally public. And there are data nerds out there in DC. They might not be the ones getting the dashboard internally, but there are data nerds and a really, really vibrant data community here in DC, a vibrant civic hacking community in DC, a vibrant data journalism community in DC that we want to open this up to and say, hey, collaborate with us. Hey, here are the best data sources in our opinion. Hey, get in touch with us on Twitter about what you're seeing that we're not seeing in this economic data. Because the problem is, for me at least, in dashboarding, there is a ton of economic data. And it is in so many different places. And I think for a dashboard to be successful, a real-time dashboard at least, and that's what we aspire to be as real-time as possible with this data, for that to be successful, it has to be pretty hands-off, which means automating getting that data in. So we don't have to, every Tuesday, when a new economic indicator comes out, do a bunch of stuff, get the data, put it in, make sure it's all correct, redo everything every time. So we built kind of a back-end infrastructure for scraping data from the data source websites with Python, just writing little quick scripts to scrape that data, to reshape it into Tableau-friendly format, because honestly that's the biggest headache is reshaping the data from a bunch of different columns into long data, or getting rid of headers, which is a nightmare, you know, all that stuff. And then designing the vizzes in Tableau, which is a one-time thing. And then just running the scraper every week or so to get new data, and then publishing those vizzes out onto Tableau Public. And if we were using Tableau Server, it would even be more automated, because Tableau Server, you can automatically schedule the extract refreshes and the postings, but we're using Tableau Public. And then we've embedded the viz code into our web page, which is hosted on GitHub Pages, which is free and open source, which means you can go to github.com/dcgov and see all of the open source projects that the DC government is working on. One of which is the Economic Intelligence Dashboard. And then the last step here is getting feedback from the public, because this is a tool for data nerds, for the community, and we want people to tell us what else should we be looking at. We want people to tell us, hey, I saw this chart, I have a few questions, and then we'll go back and do some more analysis on it. And we have now a chart of the week, as of today, a chart of the week kind of blog function where we're going to do some more deep dive analyses like that. We've had some great feedback on Twitter so far. In fact, some of the charts that we've put up on the dashboard are in direct response to some questions we've gotten from the data journalism community on Twitter. And I would say actually right now, data journalists are the biggest users at the site. I'm going to do a little demo, walk through our automation process, our posting process, and then walk through some of the data that's actually up on the site. Any questions before we move on? All right. So I'm going to go to the site here. This is what it looks like. We have everything organized kind of by topic to keep it simple, to show just one thing at a time, population, etc. I'm actually going to select this chart down here, unemployment rate, and go through the process, the old process that we used to use to get this data, update this data, and display it, and then walk through the more automated process. So this data, the unemployment rate data, is here, as well as other places, but this is the easiest format to get it from Fred, from the St. Louis Fed. So I could go to this page and say, oh, all right, there's new data. Yep, February, that's new. Up until March, we have for US. All right, I'm going to export this to Excel. All right, yawn if this is boring. It is. And this is what we end up with. So not great for Tableau, right? There's some headers here. If I wanted, I could probably make this into long data if I wanted to use the series as a dimension, for example. So we've actually automated that process, the process of getting the data, downloading it from the website, reshaping it into Tableau-friendly format through this little Python script, which is on my GitHub if you want to ever use it. And there's a good API that Fred has put out that it makes it pretty easy to do. Just this little script here gives us an Excel file. And I'm actually going to run the update script here. I'm going to say Python Fred unemployment. It's going to scrape the data. If my internet connection is working, since the file is in my network files, either way, all right, it's done. And then I'm going to go to my Tableau workbook here. This is what we've pushed out to the site. We're going to update this data source. And again, if I were using Tableau Server, these steps could be unnecessary. The extract is updated, should be. Yep, 2 more data points. So the February unseasonally adjusted data is out now. So I would redo this annotation It's a workaround, it's not a data label, it's an annotation. And then I push it out to Tableau, public. I'll just do that really quick now so you can see the process. And then I will refresh once it definitely has exported to Tableau. I'll refresh this page, and it's updated. I'll go back later and change this little label here. But basically, that's the process. We are using Tableau Public for specific government bureaucracy reasons right now, but eventually we'll switch over to Tableau Server, and this will be all automated. Although I will say I don't want everything to be automated for the specific reason that I still want to force myself. I want a forcing mechanism to make myself look at this data on a regular basis so that I still have that time in my week to do that analysis to make sure that everything is still good in DC. And that's kind of the best forcing mechanism for me right now, is to have to push out the new data every week. So that's our process. And I just want to walk through a few other pieces of data we have up here. We're right now using a combination of D3 and Tableau to visualize data on the site right now, and just plain old HTML tables. But for the first time on this site, we actually have data about the affordable housing projects that are going on in DC. This data has never been put out before, at least to my knowledge, on a project-by-project basis. So we have all of the affordable housing projects which were delivered between January 2015 and today in this table here, organized by ward. And we have all of the affordable housing projects which are under construction, which started since January 2015 here. And you can see on the map exactly where all of that affordable housing is going by number of units. So you can drill down into your neighborhood and see where's their affordable housing coming. We also have the same thing for DEMPED real estate development projects. And it's kind of a Venn diagram. Not all DEMPED projects have housing components, and then not all affordable housing projects are DEMPED projects. Because there are other agencies also that produce and preserve affordable housing in DC. You can see all of the DEMPED projects that my office is involved in. Walter Reed up here, the wharf down here, various other construction projects, Skyline Town Center, St. Elizabeth's, etc. And actually see what the DEMPED portfolio is for the first time in real time. Let me just quickly walk through some of those figures that I was talking about earlier. And this is more, these visualizations are more about what is the most current number that I need to know. This is a one-stop shop kind of for, I need a baseline stat on DC. Oh yeah, 672,000 people live here. Has it been changing? Yeah, actually, look, we're in the middle of a population boom that hasn't really happened on this scale since like the 1960s, the early 1960s. Move over to employment. How are jobs doing in DC? All right, that line's going up, pretty good. That's all really that matters. Then I want to drill down a little into the sectors that have been growing in DC. We have this chart here. This is actually in response to a request from someone on Twitter. And one thing that I want to also highlight, it's not all good news in DC. Some things that we're tracking have actually raised some red flags, like this chart here, average hourly wages in DC. Blue line is DC, gray line is US. DC, higher wages hourly than the rest of the US, not uncommon for an urban area. right? But actually, since about mid-year last year, wages have been falling year over year. That raises a question mark. That says to me, we need to look into this. We need to figure out what are our hypotheses about this and do a lot more analysis on the reasons behind this. Is it because, for example, the retail and service industry has been gaining in jobs in DC? You can go over here, accommodation, food services. Yeah, that's like a more low-wage industry. It has been gaining. That could be why. Is it a demographic question? Are a lot of high-paid workers retiring now? Is there a retirement wave that's driving the average wage lower? Do we need to get some distributional data? The dashboard isn't really going to answer all the questions. It's going to create questions. It's going to give you some ways to formulate hypotheses, but it's not the end-all be-all for answering or projecting out economic trends. What's going on? So I think that's about all I have. If there are any questions about either the data or our process or DC government in general, I'm happy to answer.
That was really good. Real quick, summarize again what your thoughts on what a dashboard is appropriate for and is not appropriate for.
Yeah, I think a dashboard is appropriate for, number one, creating and disseminating a baseline level of knowledge on a few key things. Keep everything simple, show one thing at a time. It's also appropriate for tracking changes. So since everything is the same always, the thing that stands out is what's changed. Process-wise, it's appropriate for building a set of key data that you want to become familiar with. And it's appropriate on a cadence level, what cadence you put it out on, for building in that structure into your job as an analyst, I think. And public dashboards, I think, are a little bit different. We're putting that out as an invitation for people to engage who like dashboards generally. So it really depends on the audience, too. Anyone else?
Okay, thank you, Marina. All right, next we have McCann, who is one of the Tableau Zen Masters and is a specialist leader at Deloitte. He specializes in predictive analytics and data visualization and also teaches a course at MICA.
It's hard to track. No, I think the way to do that.
All right, everyone. My name is McCann. I work as a specialist at Deloitte Consulting. I'm going to do something a little different today. Usually I give a lesser version of John's presentation, so I'm glad I didn't do it. I'm embarrassed by how awesome John really ruined my presentation. I'm working on a new one sitting here, but I'm going to do something a little bit different today. So it's the first time I'm doing this, so please be patient. And a lot of the stuff I'm going to show today is pretty new. I haven't pushed out to my website. If you want to visit my website, it's at duelingdata.com. But I do a lot of analysis on politics and entertainment, movies, sports, and then music. But today I want to talk about something I call Ana-lyrical, which is a focus of the intersection between data and music. And this was really inspired by a viz I created recently. It was a Beatles visualization around who wrote most of the Beatles songs. And it got a lot of attention. And I realized there's a pretty strong intersection between the data visualization community and the analytics community, and people who tell stories with data and musicians. And I'm going to walk through an example of that. Story points is hard. I'm going to start with Justin Bieber, as you do with any good presentation. And the reason I start with the Biebs is because he put out a song over the summer called "Where Are You Now." Is pretty, it's a fun little song. But the reason I highlight the Biebs is because he was featured in a New York Times data visualization around the development of this song, the production of this song, and how he worked with two producers, guys named Skrillex and Diplo. It sounds like I have to saying those names over and over again, but they are music producers and they're very talented. And what they did was actually, the Biebs was in trouble, as you can tell here, smiling in his mugshot. He got arrested, and his career was sort of stagnating. He was going through growing pains, as any 12-year-old musician would, and his people decided they need to reinvent his career. And so, in order to reinvent his career, he knew that his people, or he, probably his people more likely, knew that the best way to sort of overcome a struggle or a problem in your career is to be successful. So he teamed up with these two producers, Skrillex and Diplo, who are DJs and traditional techno music producers, and created a new song. He essentially bought his way back into success because these are music producers who are essentially for hire. They created a song for him, and the New York Times actually walked through the process of creating this song. And they visualized it, so it's a multimedia presentation. It's on the New York Times website. It's excellent. It's 8 minutes long. It'd probably be better if I just showed it and then stepped away. But it's a beautiful visualization, as a lot of New York Times stuff is, where it's mixing 3 elements. It's mixing a video interview with the Biebs, Diplo, and Skrillex, music in the back, so the actual song and different versions of the song as they create it. And then they have these other annotations that are rendered on the side as the video and the songs are playing over time. And so you have, on the left, you have the percussion in red, and the beats follow as the beats are created and generated for the song, sort of underlies the song. In blue, you have the piano or strings or guitar instruments that are created as part of the song. And then on the right, you have the Biebs, or Justin Bieber's vocals that they took and distorted in order to create new sounds. And what I thought was interesting about this is not just the visualization was created, which is excellent. And again, I encourage you all to go check it out. But one of the quotes by, so this is Skrillex, he's one of the producers. And the two producers actually brought their computers. These are the instruments that these musicians use to create new music. They create music on computers. They are using music software to bring in sounds and bring in data points to create new stories and to create new songs. And this quote by Mr. Skrillex I thought was pretty interesting. It says, if you compare it to a painter, I don't think it's this room, but if you compare it to a painter, so much of the process is literally just getting the colors right. And I think he compares it to a painter, but that resonated with me because that's what at Deloitte I teach, at MICA I teach, is most of your time, 80% of your time, should be spent just getting the data right. I mean, it's where we spend most of our time is actually in the data sets. And Skrillex was explaining, like he spent hours and hours and hours just taking in sounds and taking in Justin Bieber's vocals and distorting them to create new sounds. Because most of the music that he's creating is sampled. It's derived from some other place. He's not playing a guitar or playing a piano. He's taking other bits of sound from other songs or from other musicians and distorting them to create something new, which is what a lot of us do in the data visualization community. We create something new with data that, from DC. The DC data that we just went over is brought into new forms and visualized and then shared with the community, and so that they can tell new stories with that data. And so that's very similar to what I think a lot of these musicians do, particularly in this day and age where music isn't necessarily created in a studio with musicians sitting around a guitar or a piano creating the music, but rather generating and producing new music. And then what I started to notice when I thought about the intersection between data and data visualization and music was that data patterns in music exist everywhere. We see data visualization and music communicated through data visualizations all the time. We see it in music sheets and music notes and sheet music. This is a nested 2D plot where your x-axis is sort of a linear plot of how you're supposed to play the song or hit the right chord, and then the y-axis is the wavelength or the frequency of that chord. In an album art, this is a famous, probably one of the most famous album covers ever. This is the Joy Division. I think it's off their first album, Joy Division, a very short-lived band, but they made a very large impression both in the music community, and then this visualization is ubiquitous. It's been put on shirts, it's been analyzed, and all it is a data visualization showing the radio frequencies of pulsars captured by a British radio engineer. And these are different ways of capturing those radio frequencies and then overlaid on top of each other to create essentially a pretty beautiful data visualization. We have Gantt charts in music software. The entire time during the New York Times interview with Skrillex and Diplo, they're showing this screen. It's a music software where they essentially have a Gantt chart where they're laying together, overlaying multiple attributes and multiple data points of music. They have their percussion, they have their lyrics, they have guitar sounds, and it's created via a Gantt chart. And so we have the duration of that sound and the frequency and the volume or the sound wave of that sound. And so this is the type of way in which music is created nowadays. This is from Jewel Laurie. Jewel is an employee at Tableau Public. She has a blog, which is excellent, and she posted this visualization, this stream graph around her listening patterns on a website called Last.fm. So she exported it out, or I don't know if she created it. I think actually the site creates it for her, but she can see cyclical patterns in her listening behaviors of when she's listening to happy, upbeat songs in red and orange here, and then when she's listening to sad and slower music in blue and purple here. And I want to explain how she found that there's a pattern that correlates to a pattern in her life that when this occurs, but it's something that where you found there are listening patterns of ways we consume music. There's ways in which we view music. This is sound waves that are in multiple media players. And this is actually a sound wave I created and pumped into Tableau. I created using a software called Audacity, which measures wavelength. But these are two different songs. And just by looking at the wavelength of the songs, you actually see patterns and structures of song that were created by the artists. And so on the top, you have John Lennon's Imagine. And on the bottom, you have a song called by LCD Sound System called All My Friends. So John Lennon Imagine follows this sort of typical Beatles lyrical and chord structure, which is verse, chorus. And you can see that present in the sound waves of the song. So you can see the first verse of Imagine, he returns to the chorus, the second verse of Imagine, and he returns to the chorus. The duration of the wavelength is almost identical in both choruses and both verses, and even the peaks and valleys of the verses are nearly identical. And this is a typical sort of song structure for pop songs lately. It matches this pattern. It's a sort of a tried and true way of creating music. This is from a relatively new song. This is from LCD Sound System. All My Friends, they're a pop techno rock band. It's hard to describe them, but this was a song that was very popular a few years ago, and you can see there's a straight linear pattern into the song. It's a song that just starts initially with piano, so it's relatively quiet, and then the volume and frequency and the layering of music on top of each other builds almost linearly over time until the end of the song where almost everything stops except for, I think, one piano key. And so we can see patterns in music just by visualizing it, the same way we can see patterns in data. So this is a Beatle visualization that I created that It's in Tableau. And these are two different songs by the Beatles. This is Love Me Do. This is one of the Beatles' most basic and early songs. It was written by Paul when he was 16 years old, still in high school, and released on their first album as one of their first hits. It's known to be a very sort of simple song. It's very easy to learn. It's only 3 chords. It's G, C, G, C, G, C, D. And it's a relatively basic song. As they got more mature and as their music styles evolved, the Beatles became a much different band from a band of almost a boy band or a Justin Bieber type of music group to something certainly more complex. And so the bottom song here is A Day in the Life. This is the last song off of Sgt. Pepper's, which many people considered the Beatles' most sort of revolutionary or a turn in a different direction. It was a response to the Beach Boys' Pet Sounds, which was a revolutionary album unto itself. But this is the last song on it. You can see the number of chords obviously increases, the complexity of the chord arrangements increase, and the overall visualization tells a story of how musicians evolve. Just by showing chord structure, I'm not even overlaying the orchestra. There's actually 50 musicians that play on A Day in the Life. Actually, 49 musicians that play on A Day in the Life outside of just the 4 Beatles. And they became a more mature, more complex band, making more unique and original music. And this is visualized here in this Tableau visualization. And this thing's not coming up, so I'm going to present it over here. So this is sort of what kicked off a lot of my thoughts around the intersection between data and music. This is a visualization I created a few months ago when my daughter was born. So my daughter is 3 months old now, and we were in the hospital. And for parents, they know that a lot of their time is just spent staying awake, really just losing your mind on caffeine and a lack of sleep. And so I was in the hospital, and the Beatles actually had just started pushing their music out to streaming services. So I was listening to a lot of Beatles and playing a lot of Beatles for my daughter because it was important that she grew up around solid, non-Justin Bieber related music. Hopefully raise her right, so she doesn't have to say words like Diplo and Skrillex. Like her father. And so I created this visualization, and this visualization is a pretty straightforward visualization. It got a lot of hits, it got a lot of attention, and I was pleasantly surprised because I didn't love the end product, but it got like 700,000 hits because it went onto the front page of Reddit. It was featured in a lot of different locations, and I was pretty pleased with it, but it made me realize more importantly that when I push out a lot of my other stuff, that things I think are much cooler than this, that this is a topic probably because it's the Beatles, but also because it's music that resonates with a lot of people because music to most people is just very accessible, it's very interesting. And then visualizing it is even more so interesting. So I'm just going to quickly walk through this visualization. It all started with this visualization. This is a breakdown of the albums the Beatles pushed out. These are the US albums. It's a key distinction because I got a lot of comments on my site around the distinction between the UK versions and US albums. But it's the US albums, and the x-axis over here is just the time in which they were published. And then the vertical bar is how popular that song was. The #1 hits are crossing over here, and then the less popular songs are down here. And then the color of the line it correlates to who wrote the song, so whether it was Paul and John together, just Paul, just John, just George, or just Ringo. No, Ringo didn't write any hits, unfortunately, so he doesn't get a line. And what it allows you to do is it allows you to see a few things. When were most of their popular songs? You can see a pretty even distribution of when their popularity started, which album, how many songs were on each album, and then who was responsible for most of their music. Sorry about that. Who was responsible for writing most of their songs? And sorry, John, but I'm using donut charts, the bullet pie charts of Evil Brother. But what you can see by using the colors of the Sankey line down here, which connect to my bar chart, is that John and Paul tended to write a lot of the songs, particularly the hits early on. They worked together a lot more frequently. 5 of their first 6 hits were written together. They ended up writing 26% of all their songs, or a total of 51 songs. And then Paul started writing a lot more of the hits as they sort of broke apart from one another. That John and Paul, and this is part of what they believed to be the animosity that split up the band, was the divergent in their musical patterns. But Paul started to write a lot more of the hits. You can see he wrote a few of the ones early on. Love Me Do is actually this one right here. But he started to have more success later on in his career. John kind of had success throughout the Beatles' career. He wrote 31% of their songs by himself. He had success in the beginning and success at the end. And then George had, he only started getting involved in hit making and really songwriting in general towards the end. He ended up writing 12% of their songs and 2 of their hits. And unfortunately, Mr. Ringo over here doesn't get a line because he only wrote 3 songs. But one of those songs is Octopus's Garden, which is an awesome song. But unfortunately, he didn't write any hits. So I'm going to scroll down. There's a few other elements to this visualization. What were most of their songs about? So this uses tokenization and keyword analysis. So removing stop words, what were most of their songs about? Not surprisingly, Love was the most popular lyric in all their songs, with the exception of Ringo, whose most popular songs were Garden and Octopus. And I think you know why. Ringo wasn't a prolific songwriter. But Love is, obviously one of the more popular things. It's featured in about 42% of their songs. And then down here is which songwriter has the largest vocabulary, and I didn't really find much pattern here. I wanted to do, there's a website called Polygraph, and they did an analysis of which hip hop artists had the largest vocabulary. And it found, I forget who it found, one of the Wu-Tang members, I forget exactly, who had the largest vocabulary in hip hop. And I didn't find much of a, it's because of the nature of their songs, it's sort of the fixed structure, or the lyrical structure, the chord structure. There's not going to be a lot of volatility in terms of the number of songs and because it's pop music, they're not going to be overly complex words or anything like that. But what I did find was, and one of the reasons I think this visualization resonated with a lot of people, in addition to it being a topic that people love, the Beatles, it was timely. The Beatles had just started releasing a lot of their music on Spotify and Apple. And also because it was a mixture of 2 types of dashboards I've seen. I've seen didactic dashboards, or sort of directed dashboards where you ask it a question and it gives you an answer, and exploratory dashboards where you see data, then you ask new questions, and then you get new answers. And so some immediate questions are answered. Who wrote most of their songs? Paul and John, and definitely not Ringo. What were their most popular songs? What were their songs about? Mostly about love. But also this bottom piece, which I sort of threw in there at the end, and I wasn't really happy with the way it came out, but this jitter plot allows you to see, the unique words, allows you to search on specific songs. The other thing you can do is if you want to click, you can actually click and see the lyrics come up on the right. So what I found was people like that it answered some questions, and I think it resonated with people topically. But also I think a lot of people like to spend time just playing around with it because they would look for their song, look who wrote it, what was the lyrics of those songs. And so it was a visualization that I put out that started to resonate with a lot of people. And I was pretty happy with that. And because this is a tug, and I know a lot of you are, most of your work is done in Tableau, I wanted to walk through one of the more complex visualizations in this thing, which is the, I call it the crown chart. I don't know what else to call it, but it's essentially 3 distinct charts combined on one another. It's a stack bar chart, it's a vertical column chart with a dual axis for the musical notes and the height of the bar. And then the bottom piece is the more complicated piece, and this is a Sankey visualization, where I stole the logic from time be the x-axis here, the height be the song, and the note be some sort of circle, and the musical note, and then the album's up here, and then a Spotify player. So actually, when you click a song, it runs into a Spotify player, assuming you have a Spotify subscription, and actually plays the song. But the hard part was all this mess down here, and it's interesting that I sort of just threw a bunch of lines on here because I knew it would be one of the harder things to create. But what it allows you to do is it allows you to see, one, it's a nice graphic sort of design element, but 2, it's a nice way of seeing distribution and patterns in distribution relative to the songwriter, and then also relative to time, since my x-axis is an ordinal scale related to time. And so what I have here is, it's essentially a path chart or a line chart. I'll show you this visualization. So it's essentially a scatter plot with line charts where in the path shelf, the path is the songwriter, or I'm sorry, the song. And so it gives the illusion of that these lines are actually curving. So I use what Jeffrey created, which was called a sigmoid function. A sigmoid function is something that, as it relates to the y-axis, sort of bends your point over time, so you have nice smooth curves. You can use Bezier curves or a sigmoid function to create a curve that's both moves left to right and right to left after it crosses a certain axis point. In this case, the invisible axis point is 0. So there's almost I think like a couple dozen circles across the vertical axis, across the y-axis, and I'm just connecting them together using that sigmoid function, and not really bending the line, but giving the illusion that the line is bending. You can download my workbook. It's on my website. And I'm going to show this, but it's stupid. You really can't see it. But you can see this is the sigmoid function. It uses an exponent to create that exponential smoothing. And then the curved line, which is what my x-axis or my columns are, to plot those points sort of exponentially over time. Yeah.
Yeah. So the function gives it its path.
Yep.
What makes it sort of narrow as it goes along?
That's a good question. I forced that. So what I did was I took the absolute value of its position on the y-axis. And so if it's thick on the bottom, it's because it's low on the y-axis. And if it's thin on the top, it's because it's high on the y-axis. So the actual values is -6, +6, because I needed to cross over 0 to create that left, right, and then right, left bend, or the other way around. I take the absolute value of that position to thicken it at the bottom and just thin it at the top. But yeah, that's how it creates that effect. But it's essentially just a line chart with a path shelf, and you can download it, sort of reverse engineer. This was the chart I wanted to create. I ended up struggling with the sentiment analysis in R. But this is actually the sentiment of the Beatles songs by songwriter. So I pumped all their lyrics into a sentiment package in R to create the sort of the polarity, the museum polarity of the song. So whether it's super positive at the top or whether it's super negative at the bottom. And then wanted to compare which songwriters were particularly positive. And so you can see Lennon and McCartney were positive. You can see by the axis point, the reference line over here, the median of their, I believe that's median, the median of their overall sentiment by song. And I'm using a logarithmic scale, so if it looks weird, it's because the scale over there is logarithmic. But what's interesting I found is that John and Paul together wrote very positive songs. John by himself tended to write very negative songs, and you can see that later on in his career as he started working with Yoko and writing sort of different style songs, more abstract songs, his tone became more negative and less poppy. Paul sort of always wrote very positive songs. George, who was a very spiritual individual, tended to write pretty positive songs, and Ringo only wrote 3 songs, 2 non-octopus related songs. And so you can just discard the sentiment. But what I think is interesting on this is the outliers. So the birthday song was written by John and Paul together. It was the last song they actually wrote together. It was a primarily Paul song, but they attributed both of the songs together. And that's one of the things I got a lot of criticism for in my visualizations. That's not a Paul song, that's not a John song, that's a whatever. And this is from their recording, their notes. After they broke up, they split up their catalog. It used to be there was 3 Ringo songs, a couple George songs, and then every other song was a Paul and John collaboration. But after they broke up, they actually went through and said, this is my song, this is your song, and these are our songs. And so the birthday song was one of the ones that they said, well, it's mostly Paul, but we're not going to get into splitting hairs and saying this is 70% your song and 30% mine. So they said it was a collaboration. It's a very positive, sort of poppy, bubblegum, sort of typical Paul song. But all the way on the other end of the spectrum, the most negative song is written by Paul, which is a Carry That Weight, which is a very sort of slow and kind of beautiful song. It's been covered a number of times, particularly I think by the band. But it's a song actually Paul wrote about how they're never going to be as successful as they were in the Beatles. And the weight is the weight of the Beatles that sort of pressure them, and that they're never going to be sort of individuals. That even John, Paul, and George and Ringo, who all had success after the group broke up, that they're never going to overcome the weight of being a Beatle. So it is a very negative song, and a particularly negative song for the Beatles, where you see a pretty large distribution in the sentiment of their songs. It's pretty scattered, and their career is pretty long. It's 4 individuals, 5 if you count Paul and John together. But what I did was I compared the Beatles to Tupac, Tupac. So I think this is the only slide ever that has Beatles versus Tupac in the history of slides, I hope. But this compares the sentiment of Tupac's, somewhat limited catalog, because Tupac unfortunately died when he was only 25 years old. But also the sentiment of Tupac's songs. So you can see, in addition to sort of the scale or polarity of the songs, we also had a designation of whether the song was positive, whether the song was neutral, or whether the song was negative. And only 38% of the Beatles songs were negative, the things down here in the orange color spectrum. 95% of Tupac songs were negative. And that could be because of the things he's rapping about. It could be because he's only one individual, and the distribution of the sentiment of his songs is so narrow because these are 4, almost 5 individuals creating music sort of collaboratively and pop music nonetheless. And this is only one individual with sort of one very narrow and unique perspective, and a very young individual who died, unfortunately, at a very young age. Even as in the song California Love, one of his more positive songs relatively, which is about, it features the word love, one of the few songs in his catalog that had the word love in it. And it is about his love of California, but it's also about how he's returning from jail. It's after he comes out of jail, and how he's struggling with his neighborhood. He grew up in Watts, or Compton, sorry. But he talks about how he's struggling with his neighborhood. And so his catalog the sentiment of his catalog is all very sort of narrowly distributed. So I thought it was interesting sort of to compare these two artists. I then started to compare other rappers and other hip hop artists, because the lyrical structure of hip hop is much more complex and much more interesting. I mean, the reason I use Tupac was because he's considered one of the greatest lyricists, and he's considered a poet of his time. He was a very talented rapper. But I also looked at Black Alicia's Alphabet Aerobics, and this is Harry Potter doing that version of the Tonight Show. I'm not going to play the video, it's an awesome video, but he memorized the entire, and for those of you who don't know, Black Alicia's Alphabet Aerobics is a pretty cool, sort of very linear song. It doesn't have a chord verse structure. It's just increasingly complex words associated with letters, so it's A, and then several words B, several words C, and so forth and so on. And on Harry Potter, he remembered all the words and performed it on the Tonight Show. So I visualized the lyrical progression of Alphabet Aerobics, which has a very sort of distinct lyrical pattern. So you start down here with A, and the speed of it, and the speed at which this the verse was sung. So the verse is always tied to the first letter of the word. So he said this verse in about 5 seconds, and the number of syllables he spoke in those words relative to the amount of time he spoke them. So it's essentially the complexity, or the lyrical complexity of that verse. And then you can see as the song builds, so it's a song that builds sort of linearly and more complex. The reason it's so impressive that Harry Potter, I don't know his real name, Harry Potter was able to do it is because it's syllabically, it's not a lot of monosyllabic words. It's very, has a lot of complex words. And towards the end here, we're at 18 and a half, 19 syllables a second. So it's a very fast song. It's a very impressive song lyrically. But we can see that pattern visualized here as the song builds faster and more complex over time. So I think it's just an interesting pattern, lyrical and chord structure, lyrical structure that's nested in the song. And then what I wanted to look at was rapper speed. So which hip hop artist tends to be the fastest? And I wasn't able to, so I scraped a lot of this data. I used Kimono to scrape a lot of my data. So I scraped, the Tupac stuff and the lyrics for the Beatles, and then the Black Alicia's lyrics as well. So this, I scraped a few websites to gather lyrics and song duration by artists. And so what this is visualizing here is who is the fastest rapper by song. And so most people believe that Busta Rhymes or Twista are probably the 2 fastest rappers in terms of syllables said per second. The problem with analyzing Twista is because he's featured on a lot of songs, particularly like Kanye West's songs. He doesn't have a very, his own catalog where he's featured solo. So it's hard to sort of really compare the complex lyrical structure of his songs, because I really need to delve into each of their songs and sort of parse out when he's speaking versus when Kanye or another featured artist is speaking. But Can You Keep Up, which is a collaboration between 2 of the faster hip hop artists, which is Busta Rhymes and Twista, it was a very fast song. They average about 6.5 syllables a second, and the entire song contains about 1,000 syllables. And just for reference, this blue dot here is Adele's Hello. Obviously, it's not, you're not going to compare a pop song and a ballad pop song nonetheless to a hip hop song, but just for a reference point, this is actually, I'm sorry, this is Adele's Hello, the dark orange circle, and that is Stairway to Heaven by Led Zeppelin. So the blue dots are rock songs, the orange dots are pop songs like Taylor Swift, Madonna. The red dots are hip hop songs. And obviously what you can see is the syllabic structure, the syllabic complexity of those songs is much higher, and then the amount of syllables they're saying per second is much quicker because of the nature of the song. But the outlier up here is Eminem's Rap God, which is a song that came out about 1.5 years ago. It's a very fast song. It's a pretty long song as well.